So as we explained, the different text representation tends to enable different analysis. And in particular, we can gradually add more and more deeper analysis results to represent text data. And that would open up a more interesting representation opportunities and also analysis capacities. So this table summarizes what we have just seen. So the first column shows the text representation. The second visualizes the generality of such a representation, meaning whether we can do this kind of representation accurately for all the text data or only some of them. And the third column shows the enabled analysis techniques. And the final column shows some examples of application that can be achieved through this level of representation. So let's take a look at them. So as a string, text can only be processed by using string processing algorithms, but it's very robust, it's general. And there are still some interesting applications that can be done at this level. For example, compression of text doesn't necessarily need to know the word boundaries, although knowing word boundaries might actually also help. Word-based representation is a very important level of representation. It's quite general and relatively robust. It can enable a lot of analysis techniques such as word relation analysis, topic analysis, and sentiment analysis. And there are many applications that can be enabled by this kind of analysis. For example, thesaurus discovery has to do with discovering related words, and topic and opinion related applications are abundant. And there are, for example, people might be interested in knowing the major topics covered in the collection of text. And this can be the case in research literature. Scientists want to know what are the most important research topics today. Or customer service people might want to know what are the major complaints from their customers about, by mining their email messages. And business intelligence people might be interested in understanding consumers' opinions about their products and competitors' products to figure out what are the winning features of their products. And in general, there are many applications that can be enabled by the representation at this level. Now, moving down, we'll see we can gradually add additional representations. By adding syntactic structures, we can enable, of course, syntactic graph analysis. We can use graph mining algorithms to analyze syntactic graphs. And some applications are related to this kind of representation. For example, stylistic analysis generally requires syntactic representation, syntactic structure representation. We can also generate the structure-based features. And those are features that might help us classify text objects into different categories. By looking at the structures, sometimes the classification can be more accurate. For example, if you want to classify articles into different categories corresponding to different authors, you want to figure out which of the K authors has actually written this article, then you generally need to look at the syntactic structures. When we add entities and relations, then we can enable a lot of techniques such as knowledge graph analysis or information network analysis in general. And this analysis would enable applications about the entities. For example, discovery of all the knowledge and opinions about the real-world entity. You can also use this level of representation to integrate everything about the entity from scattered sources. Finally, when we add logical predicates, then we would enable logical inference, of course. And this can be very useful for integrative analysis of scattered knowledge. And for example, we can also add ontology on top of the extracted information from text to make inferences. A good example of application in this enabled by this level of representation is intelligent knowledge assistant for biologists. And this is an intelligent program that can help biologists manage all the relevant knowledge from literature about the research problem, such as understanding functions of genes. And the computer can make inferences about some of the hypotheses that the biologist might be interested in. For example, whether a gene has a certain function. And then the intelligent program can read the literature to extract the relevant facts by doing information extraction, and then using a logical system to actually track, let's say, answers to a researcher's question about what genes are related to what functions. So in order to support this level of application, we need to go as far as logical representation. Now, this course is covering techniques mainly based on word-based representation. These techniques are general and robust, and thus are more widely used in various applications. In fact, in virtually all the text mining applications, you need this level of representation and the techniques that support analysis of text in this level. But obviously, all these other levels can be combined and should be combined in order to support the sophisticated applications. So to summarize, here are the major takeaway points. Text representation determines what kind of mining algorithms can be applied. And there are multiple ways to represent text: strings, words, syntactic structures, entity relation graphs, logical predicates, etc. And these different representations should in general be combined in real applications to the extent we can. For example, even if we cannot do accurate disambiguation of syntactic structures, we can still get partial structures extracted. And if we can recognize some entities, and that would be great. So in general, we want to do as much as we can. And when different levels are combined together, we can enable richer analysis, more powerful analysis. This course, however, focuses on word-based representation. Such techniques have also several advantages. First, they are general and robust, so they are applicable to any natural language. That's a big advantage over other approaches that rely on more fragile natural language processing techniques. Secondly, it does not require much manual effort, or sometimes it does not require any manual effort. So that's, again, an important benefit, because that means you can apply it directly to any application. Third, these techniques are actually surprisingly powerful and effective for many applications, although not all, of course, as I just explained. Now, they are very effective, partly because the words are invented by humans as basic units for communications. So they are actually quite sufficient for representing all kinds of semantics. So that makes this kind of word-based representation also powerful. And finally, such a word-based representation and the techniques enabled by such a representation can be combined with many other sophisticated approaches. So they're not competing with each other.